Okay, here we go with the solution guide to your study guide for the definite integral quiz. All right, so here's our key. We have the first question. We're looking for the total number of barrels of oil that pass through the pipeline. We're given the rate at which the oil flows in barrels per hour. All right, so we see 100 barrels per hour going up to 200 barrels per hour, back down to 100. This is an area under the curve problem, and we have to approximate since we don't have an exact formula for this region. But we do have 1, 2, 3, 4, 5, more or less 5 of these grids that we can just add up to find the area underneath. The question is, how many barrels is each grid worth? Well, we have a base of 6. We have a height of 100. 6 times 100 is 600. And there are 5 of them. So 5 times 600 is about 3,000. That's our answer for the first question. Okay. Moving to question number 2. We have this graph of f. It's 2 line segments as shown in the figure. We have to find the value of this definite integral. Okay, now if it was just f of x and not the absolute value markers, if it was just f of x, we'd be looking at the area of this trapezoid, and then the area of this triangle, and then the area of that triangle. Okay, however, these 2 triangles would wipe each other out, and therefore we would only have this trapezoid. But since it is the absolute value, what we need to do is put that absolute value of f into play. What does an absolute value do to a negative value? Exactly, it makes it positive. So if we look at f of x is positive, f of x is positive, but as soon as f of x becomes negative, well, the absolute value markers make it positive. How does it become positive? Well, it reflects over the x-axis. So this graph right here is the absolute value of f of x. So really we're taking this triangle and now we're looking at that region, and we're no longer interested in this region down here because our graph must be above or equal to the x-axis. So we have the area of this trapezoid plus the area of that triangle plus the area of that triangle. 5 halves. All right, flipping over. Now we get into our approximations. We have this graph of f. We have to determine which of these 5 choices is the least value. Okay, well, this is one in which we start making some drawings. We've got a left Riemann sum. All right, that means that the upper left-hand corner of the rectangle must touch the curve, like so. That's definitely an overestimate. We want the least value, so the left is out. Okay. Let's go. That means that the right will be an underestimate. If the left is an overestimate on a decreasing function, then a right rectangle will be an underestimate. So this is a possibility. Okay. Midpoints, they crisscross, and some will be above and some will be below. That's pretty hard to figure out if that's an over or an under. We know it's going to be pretty exact, and the right is definitely missing a lot. So the midpoint might be an underestimate, but it's definitely not going to be the least value. So the midpoint is out. Okay. If we go with the trapezoid sum, all right, well, the trapezoid sum would be something like this. Okay, so that is an underestimate as well. But if you think about a trapezoid sum compared to a right rectangular sum, all right, that right rectangle is going to be missing a whole lot more space than the trapezoid will. So while the trapezoid is a possibility, the right one is going to be smaller because it's not as accurate. But speaking of accurate, this is the exact value. It's not an overestimate or an underestimate, it's the exact value. And the right Riemann sum we know is an under approximation. An under approximation beats an exact value in this race for the least. So it's down to these two. The right one is more of an underestimate than the trapezoid, because the trapezoid we know is more accurate, so we're going with right for number 3. Finally, with number 4, okay, we have to figure out which of these 5 values could be an approximation for the integral from 0 to 3 of f of x dx. All right, well, we also know that f is increasing. Okay, if the function is increasing, like so, then we know that a left sum is going to be too small. And we know that a right sum is going to be too big. So if we do a left sum and a right sum, we have our bounds. All right, so when we do our left sum, that means we're going to have the 0, the 4, the 10, the 18, the 28, and the 40, but we don't use the 54. All right, now in each case, our delta x is half a unit. All right, so when we do our left sum, all right, our base is always going to be a half, and I'm just going to do this all at once. So base times height plus base times height plus base times height, so on and so forth, but the base is always a half, so let's factor that half out. And then we have all of our heights, 0, 4, 10, 18, 28, and 40. All right, so we have 4, 14, 32, 60, and 40. 60 and 40 is 100, so we have half of 100, which is 50. Okay, so that's too small. So there's our 50. That's why 50 is there, because they want you to pick that because you did a left sum. But we know that that's too small. So 50 can't be in. All right, now we go to the right. Okay, well, when we do a right sum, same thing. 1/2 can get factored out, but this time we're not going to use the 0. We're going to use the 4, 10, 18, 28, 40, and 54. There they are, 4, 10, 18, 28, 40, and 54. All right, now this value will, again, we're using the 4, we're using the 10, we're using the 18, we're using the 28, we're using the 40, but we're using 54 instead of 0. So this number is going to be 54 higher than the previous number. All right, so instead of 1/2 of 100, we're going to have 1/2 of 154. Half of 154 is 77. So 77 is a right sum, but we know that a right sum is too big, so that's out. But if the left sum is too small and the right sum is too big, then 62 is a possibility. So there's your first 4 answers for the study guide.